Hello student, welcome to EaseMyStudy YouTube channel. I am with you Abhinandan Kumar Jha. In this class, I am going to start the new topic, electric potential due to an electric dipole. So in the previous class, I have discussed that what is an electric dipole in detail, each and every concepts. If you haven't watched the video yet, please watch the video first. Link is given in description and also in I button. Let's start today's lecture. We'll discuss the electric potential and also the derivations. Derivation is important. Sometimes you're preparing for the board examinations, and also it will give you while you're solving the numericals for JEE mains or advanced, particularly the advanced examinations. If you understand the derivations, you can solve the various numericals. If understanding the derivations gives the concepts building to the students, and if you understand this, definitely related problems can be solved easily. So this lecture is important. And sometimes in the board examination directly they will give the derivations for this electric potential due to an electric dipole. Let us start today's lecture. So first we'll make our electric dipole and we'll see that where we have to find electric potential. So take a charge. Here, take the two charges. I will make it in middle because I have to take some points here. So I'm making it here. The two charges, one is the plus Q and other is the minus Q. So I take generally minus Q, as in the first lecture you have seen that. And it is separated by a small distance. Say some distance. This is some Q2 minus Q. Now you have to mark the center of the dipole, which is the midpoint of this D. The distance from here to here is D. If you say the distance, which is separation of these two charges. So this is the basic. Electric dipole is given, minus Q plus Q, you put it and the distance D is given. Now you have to find the electric potential somewhere at a distance P. Now what is the relative idea of this D and at this point P? So suppose this point is basically P is written is at a distance of R. But can you imagine that this R is near to Q? No. In the definition, we are assuming that this R is much greater than D. This is the assumptions. We are assuming it here that the distance where you want to find electric potential at point P, which is far distance from the center of the dipole. And if you want to mark the center of the dipole, you can mark with, generally we mark the center as O. So here I am marking it as O. So this center is O. Now if you see that I have slightly made an inclined, right? For general we will make it inclined. Now, if it is at 90 degree, then what will happen? If it is some 0 degree, then what will happen here? So generally, we don't make the derivation for 90 degree or the 0 degree. Here we'll make a general case when your point P is at a distance of some angle theta. Right? So if theta will be 90 degrees, then the point will be at the perpendicular bisector, or sometime the point may be on this axial line. So I will take two separate case for this perpendicular and the axial line, but this is the general derivations here when the point P is at a distance of theta from the electric dipole moment directions, that is in between minus Q to Q. Understood? Now you have to find electric potential here. What is the BP? So everything is given here. So now you know in the physics, this is the basic case. You have to find it. Now we have to take the component also here. So what I am going to do is I am going to make this point from this minus Q charges and also from this plus Q charges. Fine. From minus Q as well as on plus Q charges. So if you make these two charges, then you can also mark this endpoint with some A and B. So it is better will be to assuming this triangle also, right? So you know that we have to find the electric potential here. So the potential is a scalar field. So potential, to find a potential due to a charge distribution, you have to find the potential due to the individual charges and simply add it algebraically, right? So I have to find potential at P will be potential at P due to point charge A and the potential at P due to point charge this B. So simply I have to find this A and this B potential and you have to add it. Okay. So what is the definition of the potential for a single charge? For a single charge, the potential formula is 1 by 4 pi epsilon naught into Q by R. Here you have to find the potential. If you have the potential at point P, you have to find the potential at point A and the point B, means minus negative charges and due to the positive charges, and simply add it. Okay. So now what is the potential at P due to the point charge A? So in general, I will say this is V1 and this is V2. For example, say. So how will you find the V1? VP is V1. So I will say that my VP will be some V1 plus V2. So what is my V1? 1 by 4 pi epsilon naught. And what is this charge? Minus Q by, what is the distance? R. This is AP. Now you have to find this AP. Right? Now V2, 1 by 4 pi epsilon naught into Q by, what is this distance? PB. So what is the variable here? 1 by 4 pi epsilon naught constant, minus Q plus Q, charge given constant. Now you have to find AP here. You have to find PB. So what you have learned earlier, the same is there. AP and PB. What is the AP here? This AP you have to find with the help of this triangle. So if you want to find the AP, you can use any formula. This is center distance. What is this? This is D by 2 and this is D by 2. Means that to find AP, AO और OA, जो भी आपको कहना है, OA and AO will be equal to D by 2. OB is equal to also D by 2. You know. So here, if this distance, this is not R, this is R. Where? So don't get confused here. Okay. Don't get confused. This R is here, this middle line. So here two distance is given, the angle is given. You can also find this distance will be 180 minus theta, and by using any triangular properties you can find it, or you have to do some, or another way is that I will increase this length, right, from here. For example, if I just increase it at some more distance and I want to take some perpendicular from this. So when I take perpendicular, why I'm taking perpendicular? Because I can easily apply the right angle triangle formula. So that's why I am doing this. Otherwise, no need. Similarly, I will make a rectangle. I will make a perpendicular from the point B. So I can apply the right angle. When I apply the right angle, I can usually apply the trigonometric ratios, sin theta, cos theta. That's why I have done this. So this is another way. Okay. So if it is theta, now this angle will be theta, because vertically opposite angle. And I have to mark the distance where it is perpendicular. So I will mark the distance, say some AA. This is my A dash, or this is B. So say some B dash. Understood? So approximately I will say that AA dash is almost, because this is same line, same endpoints at the middle point, AA dash will be equal to BB dash. And also the AP is approximately equal to A dash P. On the next segment, you see this AP, I will also take it here. This AP will be approximately equal to A dash P. Why? Because this P is at a very far distance from the center line. So this perpendicular is not too big. So if some quantity is very large, for example, I have 1 crore rupees, and if I give you 1 more rupees, you say countless. Understood? So that is the case if it is very far distance. If you added some distance, it doesn't matter. So AP approximately equal to, either I am taking the congruent, but this is approximately, which is A dash P also. So if you want to find A dash P, which will be equal to A dash P will be A dash O plus OP. So I have to find A dash O and O dash P. How I am going to find this? So OP will be as it is. In the previous case, here you see O2P, we know this is R. Now I have to find only the A dash O. So if this is D by 2, this is perpendicular. So what will be this is the base. O dash A is the base. So I will apply the cos theta. So if you apply the case, then this will be AA dash upon, if you apply the cos theta, then you will get the base. So OA dash by D by 2. So I will find that cos theta will be equal to here the base, which is O dash A by D by 2. So here O dash A is equal to D by 2 cos theta. Now you have to find what? You have to find A dash P, which is A dash P, which is equal to OP plus A dash O. OP plus O dash O. What is OP? OP is R. What is O dash A? Which is D by 2 cos theta. Understood? Similarly, you have to find the inside. If I have to find the distance from this B dash P, okay, and OP, you have to find BP and B dash P will be almost same. So there is one assumption that I'm going to use here, that BP is approximately equal to B dash P. Again, the logic is same. If it is just very far distance, I have a very far distance, if I am taking from here, it is negligible. If I am saying this is a 20 centimeter is there, and here you are taking just 0.1 centimeter, so it can be neglected. So that is the case here. It is at a very far distance. And then if you want to find the BP, so this will be equal to, if you see it here, this will be OP minus B dash P. OP minus B dash P. What is OP? I know R. Then I have to find B dash P. So to find the B dash P, we know this is theta, this is 90 degree. You can easily find the B dash P also, because this is right angle triangle. This is 90 degree. So again, by using the trigonometric ratio here, you have to find the O dash, which will be again the D by 2 cos theta, and I will say this is the R minus D by 2 cos theta. If you have any confusion, you can write it to me. Simply, this is a simple geometry. You will understand R minus D by 2 cos theta. So now I have the A dash P, I have the B dash P or BP. Okay. So that is required here in AP or also the BP. Okay. So now I have the BP. This is also AP. I can put it in this equation 1 and this equation 2. And then I can find the BP. So BP is equal to V1 plus V2. Substituting the value of AP and BP, write it here 1 by 4 pi epsilon, which is constant in both the case. You can see it here. 1 by 4 pi Q, you can take is at also the common, or let it be at this time. This V1 is, and what is the AP here? This AP, you can say it here R plus D by 2 cos theta. Now, and then minus Q by R minus D by 2 cos theta. Because this is the negative charges. One is positive, another is negative. So I have added that. Just simply we have taken the values and you have just added these values. Now you have to take the LCM. You see r plus d by 2 cos theta, a plus b, this is a minus b, r square minus d square by 4 cos theta. You have to take the q outside. So on the next page I am going to write it. Okay, so here the first thing is the minus q by ap. So here I have written minus q and my ap is r plus d by 2 cos theta. AP is r plus d by 2 cos theta. Here you see this is your AP and I have written minus q by r plus d by 2 cos theta, and this is my plus, right? So here you can write it on the next page that 1 by 4 pi epsilon naught, I'm writing it here, q upon r minus d by 2 cos theta and then minus q by r plus d by 2 cos theta. Okay. So here you have to find 1 by 4 pi epsilon naught into q, and then in the denominator what is there? A minus b, a plus b. So r square minus d square by 4 cos square theta. Now again it here q, this is the plus q. If you take the plus q, then what is that? R plus d by 2 cos theta, r plus d by 2 cos theta, and then minus q already I have taken, so no need to take it. Q is here, and then this will be, and minus r plus d by 2 cos theta, minus r plus d by 2 cos theta. So here r se r get cancelled, and I will write 1 by 4 pi epsilon naught into q into here d by 2 cos theta, d by cos theta, 2 into d by 2 cos theta, you will get the d cos theta divided by r square minus d square by 4 cos square theta. So this qd, you know p is equal to q into d, this is the dipole moment. So I can write 1 by 4 pi epsilon naught into p cos theta divided by r square minus d square by 4 cos square theta. What happens? D is very small. D is very small. D square is again very small. Less than. Now d square by 4 again less than cos square theta, any angle theta. So if you subtract, and r is very large, r is much greater than d. So if r is very large, you can significantly say that this can be equated to the r square simply. So if I have infinite rupees, if you subtract it, if you take 1 lakh, I do not matter, it doesn't matter. So something like that, the distance is very large. So you can say that it can be approximated to r square. So I will say that the electric potential will be at point P will be 1 by 4 pi epsilon naught into P cos theta by r square. So this is the electric potential. This is the electric potential due to an electric dipole at point P, which is at a distance r, which is at a distance r, from center of the dipole at an angle theta. Okay, so this is the definition of the electric potential here. Now the two cases arises. So now we have seen that this is the general case. This is the general case for any case. Now suppose the question comes in the examination, one question will be like that, which is on the screen, that derive an expression for an electric dipole. Derive an expression for an electric dipole which is at a point P at a distance r from the center of the dipole. So the question comes like that. So you have to find that. Now, if the question comes like that, you have to derive the electric potential due to a dipole when the point is on the axis of the dipole. So here I will going to consider the case 1. Case 1, when the point is on the axis of the dipole. Axis of the dipole means that if it is a dipole from here to here, minus q, and now your point is somewhere at P on the same axis. This can be of any side. It can be on the negative side or positive side at a distance r from the center. This point P, right, up to this location, you have to find that. So here you do not have to separately find it. Understood? You don't have to separately find it. What exactly you have to find it? That if I'm going to find the electric potential here P, so I will take the general case. What is my general case? We'll write, we have Vp is equal to 1 by 4 pi epsilon naught into Q by QD, not right, P cos theta divided by R square. Now, here, what is the theta here? Theta will be 0 degree. So, for the axial position, the theta will be 0 degree, which is also called as the end-on position. This word is called as end-on position of the electric dipole. In some book, it is written there. So, for end-on position, theta will be 0 degree. Because in general case, where was my point P? Theta. Now this is along this line P. So now theta will be 0. This is somewhere on the axis. So theta will be 0. So now for theta 0 degree, can you tell me that what will be the Vp? If you put theta, cos 0 will be 1. This is 1 by 4 pi epsilon naught P. Cos theta is 0. This is P by some R square. Okay. Now the second case, the case 2. Suppose my point is, the point P is at an angle of 90 degree. Means in this case, theta is located 90 degree, which is called as the transverse position. Transverse position. In some book, it may be written broadside on position. Broad, B-R-O-D, broadside on position. So for such case, theta is 90 degree. I will use the general case where I say in general, Vp is equal to 1 by 4 pi epsilon naught into Q by D square. So this is not the general here. You have to write the general case P cos theta by some R square. So if theta is 90 degree, cos 90 degree is 0, and this Vp will be 0. So when I say that the potential due to the bright side on position, okay, bright side on position, this value will be 0. The electric potential when the point is perpendicular bisector, we can also say the perpendicular bisector. Okay. So when your point is at the perpendicular bisector, the electric potential will be 0. For example, in this case, this was my dipole from here to here. Minus Q and then plus Q. This is the point P. This is the minus Q, your point P, and then this is the distance from the plus q. Now your point is located, from the midpoint, from the center, somewhere here, the perpendicular bisector. I say this angle is 90 degree. Understood? So now you have to find at the perpendicular. You can independently find. For this case, you can independently also find that. No issue. For independently means that you don't have to use the general case always. You can use simply taking the distance r1 here. This is the distance r, and you can just a or b, and this is o. By using the trigonometry, you can find the distance. You can simply add it. Potentially, you have to find the potential due to minus q and plus q separately, and you have to add it for this triangular case, right? So the distance between this a and b will be the d. I am taking it considering the small d. This is the broadside and position when the perpendicular bisector, the theta is 90 degree, and the electric potential here will be 0. I hope so. You can independently, again I am emphasizing, you can independently solve it. Okay, that is not required. So now the question arises, sir, in the examination, if the question comes like that, derive an expression for the electric potential due to an electric dipole at the perpendicular bisector at a distance r, at the perpendicular, or for the broadside down position, like that. So if the right side position, transverse position, perpendicular at a distance r, you have to derive the general case and then take the special case when theta is 90 degree. For this case, theta 90 degree, so you can say the 0. This is also the way. Another way, you can directly make this diagram here on the screen, and then you apply this. So if you need this, the separate derivation, direct derivation based on this diagram, so please write in the comment box. I will do that for you, but it is not required. On your request, I can do that. So I hope so. In this class, you have understood the electric potential due to an electric dipole at a point P, which is situated as r at an angle theta, and also two special case when the for the end on position when theta is 0 degree, and for the broadside down position when theta is 90 degree. So see you in the next class, guys. If you have liked this videos, please like, at least give a like, and you haven't subscribed the channel yet, please subscribe the channel, so that in the next class, electric field due to an electric dipole, and also lots of more lectures are coming in the sequence. Also, I am going to give you another lectures when the dipole is placed an external electric field. So when I say electric field, definitely that is very useful video will be there, because the dipole itself has some electric field, but if I put it in some external field, there is a field, then what will happen? So that's excitement. Subscribe the channel. Thank you, guys. Take care.